Welcome to the Discover Mathematics series. In this video, we're going to look at the angles formed by parallel lines cut by transversal. First, have students draw two non-parallel lines and a transversal. I labeled my lines L and M and the transversal T, and then I numbered my angles as such so that it makes it easier to talk about. Then have the students measure all of the angles. Then, after the students have measured all of their angles, we can ask them what angle relationships do they notice. And they should notice, they should be able to tell you that our vertical angles are congruent. They might tell you by numbers or use the words vertical angles. Okay, in addition to the vertical angles being congruent, the students should notice that there are numerous sets of linear pairs, like angle 1 and 2, angle 2 and 3, 3 and 4, 4 and 1. So the linear pairs are going to be supplementary, and they'll notice that any two consecutive angles are going to be a linear pair, or any two consecutive angles are going to be supplementary. This is information they've probably already worked with. Now what we want to do is have the students redraw their diagram, but having the lines parallel and a non-perpendicular transversal. It may be helpful to have them label the angles the same way. After they've drawn their parallel lines, then they can go ahead and measure all of the angles. And then after they've measured all of their angles, then you can ask them what else, or what do they notice about the angles. They should be able to tell you that, just like in the previous diagram when the lines were not parallel, that the vertical angles are congruent. Any two consecutive angles are going to be supplementary, but they should notice more. Now they may tell you the angle relationships by their number, or they may tell you by using the vocabulary words. But they should be able to tell you that as a hypothesis, they're just this is a conjecture. On their diagram, they can see that angles 2 and 6 are congruent, and those are corresponding angles. They can see that, and then they'll see that all the corresponding angles are congruent. They'll be able to see that our alternate exterior angles, like angle 1 and angle 7, are congruent to each other, and they'll also see that angles 4 and 6, the alternate interior angles, are congruent. Okay, at this point, these are conjectures. They're observations that the students made, and then you can go ahead and prove these. But initially, let the students make the observations before you prove the theorems. Now, another question to ask is, does it matter if the lines are parallel? Well, we know that it does make a difference, because that's why we do the non-parallel ones first. But we can also see that since it does matter when the lines are parallel, that's the only time the alternate interior angles are congruent, then the converse of each of these two conjectures is also going to be true. That when you have lines cut by a transversal such that the alternate interior angles are congruent, then the two lines have to be parallel. So by drawing the parallel lines and measuring the angles, the students can discover three hypotheses, which will become corollaries and theorems, and the converse of the three. And then you can go ahead and prove them after they first discover them and propose them as conjectures.